Excellent. Okay, so we're going to talk about Nodecopter. I'm Andrew, T-Bass on Twitter. That is my rabbit, Bertram. He's also on Twitter. I can't really make it out here, but he is Mr. April 2014 in the calendar, which makes him slightly more famous than me. I run the London Node user group. Been doing it for about 2 years as kind of a fun aside to my day job, which is where I got interested in and kind of found out about Nodecopter. And I also run organising the Great British Node Conference, which is the first time I've ever organised a conference, and it's pretty hectic, so props to the guys running this, which is 6 times as big as what I'm putting on. So Nodecopter, it's basically an event/library that was created by this handsome German fellow, Felix Geisendorfer, when was it? Last year, about October time, where he basically got one of these AR drones for Christmas and was hacking around with it and reverse engineered the interface for controlling it using an app so that he could programmatically fly it around using Node.js. So he then created a library which he published on NPM, the module hosting service for Node.js, which is called AR Drone, and set up Nodecopter.com, which is a kind of an open source event where basically anyone, they give you all of the documentation for how to run a Nodecopter event, and then let anyone basically run an event anywhere in the world. So they run some in Germany, and I've been running a few in the UK, in London, Southampton, Bristol recently, up in Manchester, kind of anywhere where there's lots of nerds around. This was the first one in Berlin, Scotland. So you see there's just lots of people hacking. It's like a regular hack day, it's just that rather than hacking on web services and things like that, the results are making robots fly around the room. There's one here in Southampton in the makerspace, and in University College London. So let's talk about the drone. We've got here an AR drone 2.0, which is what we use for all of the Nodecopter events. It's basically a big toy, quite an expensive toy, about £260 on Amazon at the moment. What's really interesting about it is it's absolutely full of sensors. So you've got a camera on the front, which is fairly high resolution, and a camera on the bottom. That's used for optical flow, much like a laser mouse, where it would try and keep the drone in the same place. Then on board inside is accelerometer, gyroscope, and ultrasound sensors for detecting how far away from the ground. Once it gets up out of the range of the ultrasound sensors, it also uses a altimeter or barometer, digital compass, and it also runs BusyBox Linux. So it shows up as a Wi-Fi hotspot. You connect to it using the idea being that you use your iPhone or your Android tablet to connect to it and control it using an app. But you can connect your laptop to it. You can even telnet onto it and then just run regular Linux commands on it. It's just a proper Linux install. There's about 512 megabytes of disk space on it, so not a huge amount of space to go playing around with it. And it's really kind of nice and easy hackable. You don't need to make any hardware modifications to get started flying it around, because the software that runs the control systems provides an API over a UDP port, so you can send it packets to tell it what to do, and the software that's running on board, which is proprietary, unfortunately, will let you give it a high-level command. Rather than controlling the motors individually, you're saying go forwards, take off, do flips, things like that. Rather than trying to worry about trying to keep the thing level, it gives you a very high-level API for controlling it. And they have since released documentation describing how to talk to the drone and tell it all of the different things it can do. as well as reading sensor data back from the drone, which you get huge amounts at about 200 times a second. It will tell you all of the things that are going on with it and the values of all of its sensors. Not the most up-to-date documentation. It usually lags quite a lot behind the latest firmware, but it lets you kind of get a grasp on it. And people have then gone on to build other libraries in other languages, so there's ones in pretty much every language that is popular. People have made an AR drone controller, because all you need to be able to do is open a socket and send down UDP packets. So Node.js, who here has heard of Node.js? Excellent, almost everyone. Who here is running Node.js in production? Few of you, it's good. This is what it says. I don't know if that's very readable. I'm not going to read it out. That's what it says on their website, but that's a little bit over the top. It's basically server-side JavaScript, runs on top of V8 from Chromium. It's just, there's no DOM, there's no visual element to it. It's all done by the command line. And it's asynchronous by default, so everything happens basically on an event loop. If you ask for a call to I/O, be it disk or network, then it's not going to block and wait for that to finish. It's going to go off and do some other stuff and then come back and tell you when its operation is finished. Usually you would handle that using a callback, or there may be some kind of nicer control flow library. But that makes it really good for working with programs that have lots of I/O or network, because you can handle many concurrent connections, because you're never waiting for them and blocking other bits of code. And talking to a drone over Wi-Fi is a perfect example of a network program where you really don't want to be blocking, waiting for the drone to tell you what its current position is, because if you get some spotty Wi-Fi interference, then your program is going to stop running and the drone will just not listen to you and potentially crash. So it's really easy to get Node. You can get it from nodejs.org. Works on Windows, Linux and Mac. There's installers for all of them. I think maybe there's a slightly newer point version, but 0.10 is the current stable release, and that works really well with all the Nodecopter stuff, and that gives you a Node command line interface in your terminal, where you can either pass it a JavaScript file, or if you just hit Node, then it will give you a REPL where you can just type JavaScript, very similar to in Chrome's developer tools in the JavaScript console. And then, as I said before, to get the AR drone library, just do npm install AR drone. npm is the package manager, and that comes with the Node installers if you use the Node installers from the website. And then you're pretty much ready to go. This is all the code you need to get the drone to take off, spin around, do a flip, and then land again. Like, you can almost build your own robot army with a little bit of JavaScript like that. This is what makes it so exciting for me. So let's try and run this. But, first of all, I have a bit of a warning. Obviously, it is a flying robot with 4 spinning blades on it. So, if it goes out of control, if suddenly it becomes sentient, then either just bat it away, don't stick your fingers near the spinning bits, that usually hurts. It's quite safe actually compared to a lot of other quadcopters. If it senses the blades blocked, then it will just stop and drop out of the sky. If it gets flipped upside down, then it will just turn off. That's its one weakness, is you just flip it upside down and you can stop a whole robot army. And if in doubt, run away or just push it away from you. But it should be fine. I've done this a few times before. Okay. So, hopefully the demo gods will be kind. I'm connected to, I don't know how visible this is going to be, but I'm connected to the drone on my Wi-Fi. And I'm going to make my terminal a little bit bigger. So I've got that same bit of code here. Unsyntax highlighted. And I can just say node demo.js, and we should get a flying robot. it's totally not going to flip. So there's a config variable whether the flip is enabled or disabled, and I'm just going to turn it on because we definitely need some flipping action today. So that was quite simple, very easy to do, and you can kind of see how we've got after blocks for making the asynchronous nature of Node a little bit easier to manage, where we're basically chaining a number of functions together and the time in milliseconds to wait until going on to do the next function. Come on, wait for the drone to connect. So trying to control the drones using a touchscreen interface is a little bit like playing a game with a touchscreen interface. It's just not as good as using a proper controller with tactile feedback for where your thumbs are. So one of the first projects that I did was to control the drone using an Xbox controller. So you can plug the Xbox controller into your Mac or PC and should be able to get access to it as a serial device really easily. There's a Node library on NPM for receiving. Yes, I have that here. For receiving all the events when any button is pressed, so you get a callback, and that gives you the name of the button. It's also set up using an event emitter, which basically very similar to in jQuery, where you would say on and then some event, say click, and then call a function when that click happens, except for the on A is pressed rather than click. So we can fire this one up. And it doesn't do anything straight away because it's now waiting for me to press some buttons. The Xbox controller lights, you can't really see them, but are flashing to tell me the state that the drone is in as well. And then the drone refuses to take off. Okay. Let's try this one again. It's just going to troll me now, isn't it? Let's try this one instead. There we go. So now, rather than very kind of fixed movements that are moving in one direction at one time, I'm able to move the a little bit of Wi-Fi interference there. I'm able to move the drone in 4 different directions simultaneously. Come back. You can't see where it is, but it's okay. So I've mapped the different controls, very similar to if you've played Halo, like a pelican for flying it around. So it's quite easy to work out what's going to happen. Although with a little bit of interference, makes it harder to keep a good control of it. Where it will basically just start ignoring, because it's UDP. There's no guarantee of any packets getting to the drone, and it will just start ignoring things if they come in out of sequence. Okay, so next demo we have is when you're flying the drone around like that. If you've never kind of played with remote control cars and things like that, if you turn the drone to face you, it's very disorientating because when you say go left, it goes right because it's facing the opposite direction. So what we can do instead is we can get a video stream from the drone, show it up on our screen, and fly using the video instead of trying to work out in your mind which way the drone is facing. So we can actually, using the very same library, get back, I'm trying to remember what the name of the command is. We can get back the video feed and we can pump that up into a web browser and show it inside of a canvas element. So this is using a library called Node Drone Stream, which is available on GitHub. I assume it's on port 3000. Oh, interference with the drone. Let's may or may not work. Alright, there we go. So this is when the node process receives a video frame from the drone. Yeah, wave around and see if it's actually very responsive. It doesn't look very responsive. I think where we have a lot of Wi-Fi going on, the drone isn't very happy about that. And then it's pumping that frame up over a WebSocket and then inserting it into this canvas element just as an array of pixels. And if we didn't have so much interference, then we should see the video is fairly... oh, we had Jason's hands up in the air for a second there. And you can then go back to flying the drone around using the controller whilst streaming the video. Oh, it seems a little bit better now. We'll give it another go. Ooh. That's a bit better. I don't kill myself in the process. You can kind of get the idea of what's going on there. Whoa. It's pretty exciting, yes. Okay, so the next progression from that, I can fly it around using the Xbox controller, I can stream the video. The next thing that I jump to is I want to make it dance to dubstep music. So we've got a little project here, which again is up on GitHub. The code's probably a little bit hard to read on this projector, so I'll just fire it up. If I can remember what the name of the command is. Yeah, that takes me. What's wrong with that? Ah. Oh, come on. Have I got the internet? The thing with having so many demos is you know that one of them is going to go wrong. Let's see how fast this internet is. Okay, that one's really not going to work. Ooh. Okay, maybe we can do this. // bin coffee server. Yeah, there we go. Horrible hack there. So we've got a CSS3 subwoofer here, and how this is going to work is there's an MP3 loaded in the browser, and using the Google Chrome implementation of the Web Audio API and a library called Dancer.js, it's going to analyze the MP3 and pull out a frequency graph. And then whenever there's a large drop in frequency, like a beat, then it's going to call a callback. And I'm basically going to toggle going up and down every time that we get a beat. So it should dance along in time with the music. And theoretically, you can swap out different MP3s to get it to dance in different ways. But if you put something like classical music in, there's not anywhere near enough of a frequency drop to get it to actually do anything. So it just kind of gently wafts around. So, let's give this one a go. Check I'm not running anything else. Sometimes there's a little bit of a mind of its own in this. So now this is like completely autonomously, so I'm not actually in control of it, other than I can say stop. I'm feeling a little bit relaxed today. Maybe not enough coffee. So you can't see what's going on here. Drifting wildly into the screen. And I don't know what happens if I make it. And when it kind of breaks on the breakout, and it kind of stops moving, it's basically not detecting any. I think it's going to crash in a second. Yeah, let's try and bring him down. Ah, that's bad. If I lose him under the stage. Battery's slightly fallen out there. But So what was happening there is the drone doesn't really have an idea of where it is in the world. It uses its downward-facing camera to look at the ground and approximate if it's drifting around. And there's not a huge amount of texture on this stage. It's mostly black and some very thin silver lines. So it probably couldn't see that it was moving around, so it wasn't aware, so it slowly drifts around with the kind of, because the blades aren't perfectly balanced, it won't stay in exactly the same place. But that's quite a fun demo. Parrot themselves, if you search for AR drone dancing, they've done one with kind of 6 or 8 drones all dancing simultaneously. A little bit harder to orchestrate in a small space like this. What else have we got? So, next thing that I wanted to do was, I always wanted to be a Scrum Master. So, rather than be a manager of people, why not be a manager of drones? So, I hooked it up with Trello. Basically, I can add, it's probably really hard to see, I can add cards to the drone's board, and then it will execute them one by one. The really nice thing with Trello is it has a WebSocket connected to every connected client, and then if you update the cards via the API, then it communicates that with a WebSocket, so it should move the cards to doing as it does it, and then done. I'm just going to remove the flip, as the flip wasn't working earlier and I couldn't get it to connect. So basically I've just got whatever the content of the card is, I'm just going to eval that in the context of the drone script. So I have a drone object. So this is just regular JavaScript. Obviously you could do evil stuff, but this is a private Trello board, so no one else can edit it on there. So there's some monstrous commands with lots of tokens and keys and things. So you can see what it's basically going to download all the cards and then start to execute them one by one, moving them around. So we go up and then stop, which should mean hover. And then go back the other way. See? No? No, it's not interesting. Oh, there we go. Slightly delayed. Again, I think a problem with interference. It really likes back behind the stage for some reason. Okay, have I got any more? So I've got a couple more experimental demos. Some of these have only been built in the last couple of weeks. I was packing one together today out on the lawn, which I think will skip, as it's probably going to be a little bit crazy without. So, who here has heard of Whobot? The campfire. It's basically like a programmatic chat bot, but it will hook up to Campfire or IRC. It's made by GitHub for basically kind of controlling and giving lots of information within a shared team chat room. So I created a script for Whobot so that I can control a Nodecopter via it. It's struggling today on the Wi-Fi to connect to Campfire, so I've just got it as a command line thing, so it works exactly the same, it's just that there's only one user in here. So I can say, Whobot take off.
No, not actually let him.
And he talks back to me afterwards as well. It's not very visible, but he says roger that. Now, this is a challenge in how fast I can type. So it should go up, or it could just crash. And I should be able to ask him to take a photo. If it doesn't fall out of the sky. Again, interference with the video is killing that. Oh, okay. Never mind that one. Oh dear. I seem to have killed the script and the drone is still flying. Oh, that sorted itself out. So, of course, when you bring programming into the real world, if your script explodes, that doesn't necessarily mean that the drone will just nicely handle your exception and land. It will often carry on flying and doing the last thing that you told it to do. In this case, it was just sitting still, but if it had crashed whilst it was flying forwards, it would have gone to the end of the room without, even if it lost Wi-Fi. So don't encourage you to fly outside programmatically, because if you tell it to go up, it will just continue to go up until you tell it to stop. Yeah, so the other one I was working on, which I think is a little bit too crazy, is I have a GPS chip which I've just been hacking on recently, which is plugged into the top, and it's reporting itself. Earlier it was reporting itself as being sat outside, and I was able to click on a Google map to tell it where to go. But flying it indoors with that may be a little bit too crazy, and it will probably just crash into people. So, let's go back to the slides. All of that code that I was demoing there is up on GitHub. There's some examples of the repos there, and then nodecopter.com/modules has a list of every known Nodecopter library that people have published. I don't know if the Wi-Fi is going to be good enough to load these videos, but I'll explain a couple of the demos. Nodecopter basically is taking the video feed, looking to see how much red is in its current kind of area of vision. If that reaches a certain threshold, then it will just charge forwards, just like a bull. So you're basically able to hold up a red flag, and when the drone sees it, it will just charge at you. Then it will go scanning around the room, looking for more red until it sees more, and then charge again, which is great fun. Harlem Shake. You can actually get the drones, because you can telnet to them, you can drive their Wi-Fi, and you can tell the drone to connect to another Wi-Fi point. And if you've got lots of drones all connected to the same Wi-Fi, and you know their IP addresses, you can control them simultaneously. And so I got 11 of them, I got one to dance, and then all of the others. It's really tricky when you have no space to test to work out what's going to happen when you fly 11 drones simultaneously. And of course, I didn't really consider what happens if two drones fly towards each other, because they have no awareness of where they are, and they all just crashed and fell out of the sky. Let's see if we can get this one to work, as it's only 30 seconds. Con los So they all just started crashing everywhere. So there's all kinds of different things you can do with them. You can control them with dance mats, so you can dance along with your drone. The dance mat is basically just a PS3 controller, so it's exactly the same as controlling it with the Xbox controller. There's also an event last year called Drone Games, where they made a kind of a competition out of their event, very similar to Nodecopter, except that there were prizes and things. Nodecopter is much more about learning and kind of being introduced to this kind of programming robots. One of the entrants was basically making the drone act like a dog, so it was on a leash, and you could pull it. Usually the drone would try and stay in the same place, but this would respond to being pulled around, and as he pulled it around the room, it also took photos of every face that it detected and uploaded them online, which got him into a little bit of trouble. So this one's a little bit crazy. Viruscopter. If you imagine that one drone runs Linux and can look at all the Wi-Fi points around it, it can also see other drones. You can also put any arbitrary code onto a drone, and because they're open Wi-Fi hotspots, you can get one drone to connect to another drone. What Viruscopter does is it will automate that, and given a piece of code, it will spread that across all of the drones, and then those drones will then go and spread that to any other drones that they find as well, which obviously results in Skynet. Hence my Cyberline Systems affiliation. Just in case it does happen, I figure I'd be on the right side of Skynet rather than the wrong side. So the drones are basically like quadcopters as a service. Because the API is really nice high level, you can mash it up with different kinds of services. You don't have to worry about the kind of, when you're getting started, the technical details of working out all of the mathematics involved, all of the mechanics and physics. You can just then start hacking on it. You can just tell it to move it around and mix it in with different kinds of services, which is really like a fun way to get into robotics. Someone's also made a virtual drone, which you can have a play with. And if you open up, this is in a project called Voxel, which is essentially like Minecraft, except for it runs in WebGL in the browser, and it's completely open source. And this is a drone object that exists in that world. And if you open up your JavaScript console, it has the same API in JavaScript inside the browser. So you can copy and paste that demo that I had in a few slides back into the console of your browser, and the drone will do exactly the same thing, which is handy for testing, but it has no concept of momentum. So when you say stop, it stops instantaneously, whereas when you say that to stop, it takes kind of a good meter before it actually has stopped and then comes back to the point where it should have. There's also some libraries in other languages. R2 is a really nice one for more than just AR drones. It works with Sphero and other kinds of robots as well. The code looks fairly nice, and if you like Ruby, then this is a great way to get into it. There's also a closure one, and the code looks like that, and to me it's not very obvious what it does really, but if you like closure, then that potentially is a good way of trying to control drones using functional programming. This was an attempt at drone art, which I think has never been done before in the way that I tried it. I basically taped a pen to the front of the drone, and I'm not sure if that's really visible here, but I think this is the first ever piece of drone artwork where I just flew the drone up against a whiteboard with the pen and drew like a square on the wall. I would sell it, but they wiped it off afterwards, so it no longer exists. So yeah, it was hacking with the GPS. This was only released a few weeks ago, and Parrot haven't made it available in the API yet. It's quite interesting. It's not very accurate, so you maybe get between 10 and 2 meters accuracy. So when you say, like, I think you're here, actually could be a good distance away. But there's some potentially interesting projects to try and feed this back in as a kind of a fairly good positional system, which then combined with the accelerometer and the gyroscope would allow you to have a much better idea of where the drone was. This was the first, my first attempt, basically logging the latitude and longitude into a Google map and dropping pins. Only problem is it does it maybe 100 times a second, so I ended up crashing the browser from the amount of pins in the DOM. Not ideal. This guy, Laurent, has made a really interesting project, which is basically bringing more robotics feel to controlling the drone without actually, again, changing anything internally. He's made a couple of projects, one called Web Flight, which gives you a nice heads-up display with a horizon bar, and very similar to if you're looking at like a flight sim and you're flying inside the cockpit, you get a very similar view, and you can control it using the keys on your keyboard or a controller plugged in using the HTML5 game APIs. And the second project is AR Drone Autonomy, which rather than telling the drone to go forwards for a certain amount of time, actually gives it a coordinate system, which is based on the feedback from the gyroscope and the accelerometer inside of it. So you're able to go X and Y and Z in a particular place. If we can feed the GPS back into that, you can potentially get a really good feedback loop, which will make it much more accurate to fly around. At the moment, as you saw, it's really not very accurate. So why is this also, why am I so excited about this? Basically, robots are coming, whether we like it or not. There are going to be drones, there are going to be all kinds of different robots within the next 5 years, just as part of life itself. And rather than fight against that, I think we should embrace that. I did robotics at university, but then never followed it on after finishing university. this was basically like how I was introduced. I can't really read the top bit. This is how my course was laid out. It was like, first of all, let's learn some advanced maths, then mechanical engineering, then electronic engineering in 2 different forms, then some computer science in the form of assembly code and C, then let's learn about microcontrollers, then control systems. Finally, at the end of the 3rd year, let's actually play with some robots. That's really frustrating for me to spend 3 years doing that. But actually is just advanced maths for 3 years with some little bits of robots on the end. Nodecopter basically flips that on its head, where it says, first of all, let's play with robots. And then when you run into the limitations of what can be done, or like, why is this happening, you then start to learn about different elements of robotics so that you can then go on to the next stage. And maybe that means you move on from the AR drone and you start playing with bigger, kind of more involved quadcopters, maybe building your own where you need to learn about mechanics and physics. Maybe then you'd start trying to rewrite the firmware for one of these, so you need to understand the Linux system on board, and you learn about Linux and all different kinds of elements. Eventually, you just have to learn all the advanced mathematics if you wanted to get up to the level of real robotics. But it means that you're actually kind of trying to solve problems and learning the things that you need to be able to solve those problems, rather than learning a load of things and then going, okay, well, now once we've learnt everything, let's hope that you're still interested, and then let's try and solve some problems. What Nodecopter basically is, let's just play with robots all the time and have a great day. So I recently took the Nodecopters to Coder Dojo, which kind of blew my mind a little bit. Coder Dojo is a kids coding club, similar to Code School, but slightly more flexible in that they don't have a curriculum. They just basically come up with all kinds of interesting stuff for kids to do. I think it's a global movement. There's definitely a couple run in London. I'm not sure where else in the UK they're running, but you can run one yourself fairly easily. And I took the drones along. So the kids that are between 11 and 15, mostly, I think. And some of them had already been along to previous events where they'd learned some JavaScript, so they had a little bit of an idea of about coding. And they picked it up super fast, like faster than experienced engineers who come along to a Nodecopter event. And the kids are already like flying around, chasing their parents around the room with these things, making them dance, and basically trolling everyone. And it's really exciting to see the way that they then started to kind of take on the ideas of robotics without having to learn loads up front. They were able to get involved straight away. I think it'd be really interesting, what with all of the movement towards coding clubs and even teaching kids about electronics and things, to maybe then introduce some element of, maybe not Nodecopter, maybe robotics in general, but they have almost every school has an amazing space for flying robots in a school hall. You could put a net halfway down the middle and basically have a flying area and a programming area, so that you don't run into health and safety issues. And imagine if you were at school and you were like 1 hour a week you got to play with flying robots. That would be like so much more interesting than everything else at school, right? But then every lesson that you're taking otherwise potentially is teaching you about how to do the next stage of the kind of robot course that you're doing. So everything is building towards robotics covers so many different topics that you could basically have lots of different bits involved to try and keep people engaged, rather than the current thing where it's like, well, let's learn about Excel macros today. So that's pretty much all I've got. This is a cat that's been taxidermied and had a quadcopter inserted inside of it. I thought that was pretty good, but then I found this, which is an ostrich with a quadcopter that is a monster quadcopter. I think that's like maybe 10 kilos with big wooden blades, like a small aircraft. Who says ostriches can't fly? So yes, has anyone got any questions?
I've got a question regarding the workshops. Are these sponsored by Parrots, or are all the...
Generally not.
No?
So for all the ones that I've been running in the UK, I initially started off getting the sponsorship from the London Node group. So I said it's for Node hackers, basically just advertised it there and got companies to sponsor each individual drone, and then asked them to lend them to me indefinitely so that I could run more events. And then I had 10 drones, so then I basically just shipped them around the country and got other people to help me find a venue that was free or cheap, so that it was really low cost and we could give tickets away for free for every event. Parrot have been involved in some of the bigger ones in the US and in Berlin, where they would give 25 drones and be a major sponsor, but it's really much more kind of free-form than being Parrot's event, where they're more interested in selling iPhone games and things like that for controlling them, rather than building a developer culture around them.
So, hold on then. Are you available for your army?
Yeah, so if you email core@nodecopter.com and you basically want to have an event run, then I'm sure we can sort something out. But generally the Nodecopter events are all not-for-profit and as a community events rather than like internal company things. Any other questions? These are about £260 on Amazon. You can get them a little bit cheaper on eBay. There's also the AR Drone 1.0, which is quite a lot older and doesn't have all of the features, but the API will still work with them, so you can actually pick one up fairly cheap. There's also a project called Crazy Fly, which is a drone maybe that big. Doesn't have the same API, but has its own programmatic API for controlling them, and that's about £150, so that's quite a lot cheaper. Or you could buy one of the really cheap remote control helicopters, get an Arduino, and open up the controller and programmatically set voltages on your RF controller and fly it like that, which is a really cheap way of doing it if you're prepared to get your hands dirty on some electronics. Great, well thank you very much. Enjoy the rest of the weekend. Oh, is there another question? Sorry.
How well does it fly in sort of more secluded areas, say up on quite high cliffs?
So it tries to do some sense of kind of balancing against the wind, but anything over about 15 miles an hour, and it really can't handle it. It's very lightweight. The bigger drones with say 6 or 8 blades will be a lot stabler and basically not be blown around and buffeted in the wind. And if this thing gets flipped more than vertical, it will just shut off as a safety feature. So if there's a strong wind, it won't be able to recover from it and it'll just fall out of the sky. So it's not great for flying outdoors. Okay? Great. Thanks very much.